Hi everybody, today I'm going to do an example of solving a log equation. We're going to do the log base 2 of 4x plus 16 plus the log base 2 of negative 2x plus 2 is equal to 5. As we're getting started, we're looking for our overall strategy for solving this equation. Generally, you have two choices. You're either looking at if the equation has the one-to-one property of logarithms or if you're going to use the definition of log. In this case, because I have two logs on the left, I think I'm going to use the definition of log, but I first need to condense these two logs into a single term. So I'm going to use the property of logs that says addition is multiplication. So instead of having the log base 2 of 4x plus 16 plus log base 2 of negative 2x plus 2, I'll have the log base 2 of 4x plus 16 times negative 2x plus 2, and that's still equal to 5. Now that I have my one log, I can use the definition. That says 4x plus 16 times negative 2x plus 2 is equal to 2 to the fifth. Now that I don't have the logs anymore, I want to work on solving this equation. We'll start by expanding the left side. 4x times negative 2x gives me negative 8x squared. Then 4x times 2 gives me positive 8x. Then I have 16 times negative 2x, which is negative 32x, and then 16 times 2, which is positive 32. Since the left side is done, we can look on the right. On the right side, I have 2 to the fifth, which is 32. On the left side, I only have one x squared term, which is negative 8x squared. 8x minus 32x becomes negative 24x. Then the 32 on the left, when I move it on the right, gives me a 0. Both of these terms have negatives, they're multiples of 8, and they have an x in common, so we're going to factor out a negative 8x. That leaves me with x plus 3 in parentheses and my 0 on the right. If I set negative 8x equal to 0, I just get 0. If I set x plus 3 equal to 0, I get negative 3. So I have these two solutions, 0 and negative 3. But before we stop, we have to remember this was a log problem, and we always want to check our solutions to make sure they're in the domain of the function. So let's take a quick look at 0 and negative 3. What we want to do is make sure when we plug these numbers into the function that we get positives. We'll start by looking at 0. 4 times 0 plus 16 is positive, and negative 2 times 0 plus 2 is positive. That says 0 is a solution. When I look at negative 3, 4 times negative 3 is negative 12 plus 16, that's positive, and negative 2 times negative 3 is positive 6 plus 2 is still positive. This tells me that both the 0 and the negative 3 are solutions to this equation.